There is a system on every commercial aircraft you have ever flown on that has the legal authority to override the pilot. Not assist the pilot, not advise the pilot. Override. The pilot's hands are on the controls. The autopilot is engaged. The flight is proceeding normally. And then this system detects that another aircraft, invisible to the pilot, not yet visible on ATC radar, not yet the subject of any warning, is on a convergence path that will result in collision in less than 35 seconds. The system does not ask. The system does not advise. It commands. In the cockpit, a voice announces, "Climb, climb, climb," or "Descend, descend, descend." And the regulatory framework of every aviation authority in the world, FAA, EASA, ICAO, requires that the pilot comply immediately, without questioning, without verifying, without waiting for ATC confirmation. The system is called TCAS, Traffic Collision Avoidance System, and the reason it was given authority to override human judgment is one of the most disturbing findings in aviation safety history. Because it was not given this authority because pilots make mistakes. It was given this authority because when two pilots each receive an instruction, their instincts, trained, experienced, professional instincts, lead them both to do the exact same thing. And when both aircraft do the exact same thing, the collision that TCAS was trying to prevent happens anyway.
To understand why TCAS needed override authority, you need to understand what happens in the human brain during an unexpected aircraft conflict scenario. When a pilot sees or is told about another aircraft on a converging path, the instinctive response, across cultures, across training backgrounds, across experience levels, is to climb, not to descend, not to turn, to climb. The evolutionary psychology is straightforward. When threatened from an unknown direction, the instinct is to gain altitude, to move away from the ground, to increase your margin against the most dangerous obstacle. This instinct is so deeply embedded that it overrides trained procedures under the acute stress of an unexpected conflict scenario. Before TCAS, air traffic controllers would issue traffic advisories when two aircraft appeared to conflict. Both pilots would receive the advisory. Both pilots would instinctively climb. Instead of separating, both aircraft would ascend toward each other. The collision risk, instead of being reduced, would sometimes be increased by the coordinated response of two trained professionals, both doing what felt right. This pattern was documented in multiple pre-TCAS incidents. It was the specific failure mode that TCAS was designed to eliminate. The solution was radical. Give each aircraft a different instruction. One climbs, one descends. And make the instructions coordinated, transmitted between aircraft on a dedicated frequency, so both systems know what each other is commanding. One aircraft goes up, one aircraft goes down. The geometry of the conflict is resolved. But only, absolutely only, if both pilots comply with what the system tells them to do, even if it contradicts what their instincts, their ATC, and their training are simultaneously telling them.
On July 1, 2002, over the small town of Überlingen in southern Germany, a DHL Boeing 757 cargo aircraft and a Bashkirian Airlines Tupolev 2145 passenger jet were flying at the same altitude on converging paths. The Zurich Area Control Center had only one controller on duty that night. His colleague was on a break, and he was simultaneously managing a separate emergency situation on another frequency. His attention was divided. When he finally recognized the conflict between the two aircraft, there were 43 seconds remaining before impact. He issued a descent instruction to the 2145. Simultaneously, on the same aircraft, TCAS issued a different instruction: climb. The DHL Boeing 757 received a TCAS instruction to descend. The two aircraft had been given perfectly coordinated opposite instructions by TCAS, one up, one down, the solution that would have resolved the conflict. The DHL crew followed TCAS. They descended. The 2145 crew initially followed TCAS, but then the controller repeated his descent instruction on the radio. The 2145 crew, faced with conflicting instructions from TCAS and from ATC, followed the controller. They began to descend. Both aircraft were now descending. toward each other. At 23:35:32 local time, the two aircraft collided at 36,000 feet. 71 people died. The TCAS coordination had been correct. The controller's instruction had not been wrong. It was issued before the coordinated TCAS resolution was established. But when the 2145 crew abandoned the TCAS resolution and followed the controller, the geometry that TCAS had separated came back together. The accident permanently changed the global regulatory framework for TCAS compliance. Every aviation authority in the world now requires that when TCAS issues a resolution advisory, the pilot follows it, even if ATC says something different, even if their instinct says something different. The system is right. The humans must follow it. That requirement, born from 71 deaths, is why the aircraft you fly on today is safer than it was before 2002.
Understanding why TCAS works and why following it is always the correct response requires understanding the technical architecture that makes its coordination physically reliable. Every commercial aircraft carries a Mode S transponder, a device that broadcasts a unique 24-bit address, like a digital fingerprint, along with altitude, position, and identification information every second. TCAS interrogates the transponders of nearby aircraft, sending directional radio pulses and measuring the response time to calculate range and the bearing to each aircraft. It does this 1 to 2 times per second, building a continuously updated three-dimensional picture of every transponder-equipped aircraft within approximately 14 nautical miles. When TCAS detects a converging aircraft and calculates that separation will fall below safety thresholds, it first issues a traffic advisory, traffic, alerting the crew that a nearby aircraft requires attention. If the geometry continues to close, TCAS calculates the resolution advisory, the specific maneuver that will create maximum separation from the conflicting traffic. But here is the critical technical detail. Before issuing its resolution advisory, the TCAS system on your aircraft communicates via datalink with the TCAS system on the conflicting aircraft in approximately 1 millisecond to coordinate which aircraft will receive which instruction. The coordination happens faster than any human communication, faster than any ATC transmission, faster than either crew has even become aware that the conflict is developing. One aircraft is assigned climb, one aircraft is assigned descend. The assignment is not random. It is calculated to produce the maximum vertical separation in the minimum time, taking into account each aircraft's current altitude, rate of climb or descent, and the geometry of the conflict. The system then monitors whether each aircraft is complying with its instruction, adjusting the advisory in real time if the conflict geometry changes. This entire process, from initial detection to coordinated instruction to compliance monitoring, happens in a timescale that no human team could replicate without the machines.
TCAS has been mandatory on commercial aircraft above a specified weight threshold in the United States since 1993, in Europe since 2000, and globally under ICAO Standards since 2003. In the years before mandatory TCAS installation, the mid-air collision rate in controlled airspace was approximately 0.5 to 1 incident per year globally for commercial aviation. In the years following mandatory TCAS installation, the rate of mid-air collisions in TCAS-equipped aircraft has been effectively zero for traffic where both aircraft carried functioning TCAS systems and both crews complied with resolution advisories. The system works, when followed, perfectly. The Überlingen accident is not a case of TCAS failing. It is a case of TCAS succeeding, issuing the correct coordinated instruction, and one crew making a human choice to follow a human voice instead. The regulatory response, requiring absolute TCAS compliance, was not a punishment for that choice. It was an acknowledgement of a fundamental truth about the relationship between human cognition and machine coordination at the speed at which aviation emergencies develop. The human brain cannot coordinate the response of two aircraft in the time available. The machine can. The machine does, 1 to 2 times per second on every flight, in every piece of controlled airspace in the world. Most flights complete without TCAS ever issuing a resolution advisory. The system runs silently. It detects, it calculates, it coordinates, it finds no conflicts that require intervention, and the flight lands normally. And nobody on board ever knows how close the geometry of shared airspace came to requiring the system to speak. But it is always there, watching, coordinating, ready to override, because it was shown definitively
that when the sky gets crowded enough, human instinct gets the same answer wrong, every time. Follow for more about the systems running silently on every flight, the ones that speak only when you need them most.